as quiet. Yes, I was just surprised by it. I wondered what I was going to do.
Sorry, trying to be supportive over here. Yeah, it's my first time. It can be a thing, right?
Hello and welcome back.
Sorry.
Today, for the first time, Marco is going to be laughing through the entire video.
Sorry.
But no, what we're going to be doing is having a look at the performance of some of our products. We have a new direct die block for Ryzen AM5 specifically, and we're going to try it against some old products. Now, this isn't going to be a review. We're not going to give our opinions about them, but we do want to demonstrate what performance you would get from choosing between these 5 products. I know there's 4 here, but we also have a 360 AIO.
Yes.
Old one. And we have a sample of what will become the direct die AIO for AM5. That's not out yet at the moment. It's just 1700, but AM5 will come. Maybe it will get slightly better than this one, but we have the first one. So explain, Marco, why you're joining me, what you do at EK.
I'm the lead laboratory technician at EK, and I'm here to help Joe with the testing and to make sure things are as accurate as possible. So hopefully we show you guys some good content and you kind of figure out where our products stack up performance-wise. So
yeah, it is actually a very intensive thing for us to show. We have to do a lot of testing so that you can fairly see every single one, and it's something that is challenging for us to get media to do independently, and that's why we're doing it ourselves for the first time, because no one wants to take their like benchmark CPU that they have all their cooler tests with and just delid it, because then they can test this one product and after that they can't test anything again. So we will take one brand new CPU. We have a new 7950X. We'll run Nucleus 240, Nucleus 360, then change to another build that has custom loop, change to the Velocity 2, and then in the custom loop build, we'll delid and we'll swap to the new Ryzen edition AM5 direct die block, and then after we'll swap the CPU back to the AIO system where we'll finally check out the direct die AIO. So what data are we going to gather for each thing, and what's our kind of hypothesis?
So basically at the end of the testing, we hope that you guys get a good idea what to expect. So we're going to show you some Cinebench scores, how like frequency-wise, how the CPU behaves depending on the cooling solution. We're going to show you like tests with controlled power wattage, so you guys can see under controlled conditions what's the difference in cooling performance, and yeah, some Cinebench benchmarks over time, so you can see that the cooling performance is not just something that is important like in a split second, like a peak performance, but how it stacks up over time and what kind of cooling solution can maintain that performance.
Yeah, we are going to have a huge range in not just the cooling engine and the contact with the chip itself, but we'll also have a huge range of radiator area, because we're going from just a 240 rad with the smallest nucleus to triple 420s with the direct die block at the end as a kind of ultimate solution that someone can just put together with typical off-the-shelf EK parts.
Yeah, so monster cooling PC.
Right, so we have to start, of course, with the CPU in its non-delided form. So we're going to start right here with the Nucleus. So we're going to begin with the Nucleus 240, which is our smallest cooler that's still suitable for the 7950X. The reason we're beginning with that is we need to start with the worst performing solution so we can set our baseline testing, our manual overclock for that solution that it can just still pass. So we're going to set up a manual overclock where at full fan speed, the 240 can just pass Prime95 for 5 minutes, and we'll get a result that's fair to compare to the other ones. Because if we began with the 240 and it was throttling, then when we move to the 360, it's just going to show the same temperature and the power usage will go up, right? So we want to see at a consistent power usage, what's the temperature from every solution, so that it's fair. Of course, for performance results, that's not what we want to show. We want to show how the performance would increase if you literally swap the cooler. So we will run Cinebench R23 with completely stock settings. We will also make every data point at 2 noise levels. I mentioned that we would base this on full fan speed, and we will also do a low fan speed, really to show the advantage of having a big loop. So of having 3 420mm radiators and the airflow that you get through that much surface area, being sort of 5 times higher in area, we want to show the noise advantage that you can leverage there. So we will also have a normalized result that we set this fan curve based on before we start. So it's not a curve, it's running at fixed 32%.
PVM, yeah?
Yeah.
At 35 decibels. So.
Yeah. Yeah, so we checked it before, it was 35 decibels at 1 meter. It's really quiet and you can hardly hear it now, so we can't show you that while we're recording it because you'll just hear us and the lights and the AC. So there we go.
Yeah.
I guess our first test should be the Cinebench score while everything's cool, that we get the 1 result.
Yeah.
Yeah.
And we're gonna show you guys the frequency, how the CPU behaves, and yeah, the score at the end. So.
Okay, let's go. Da-da-da-da-da. So we finished our testing with the Nucleus 240mm AIO. Everything went nicely. Everything pretty much was as expected. We saw a nice bump in the scores when it went from 35 decibels to full fan speed. The only thing which did not pass was our manual overclock in Prime95. When we tried to run at 35 decibels, when we tried to run the low fan speed, the CPU hit 100 degrees and then forced the fans to 100%, so it just became the other test. So at the end, we'll have to put kind of a fail at that threshold, at that noise level. It's not possible to sustain the same heat load as we'll have with the later coolers and with the full fan speed.
Yeah, true. So as expected, kind of.
Yeah, kind of, because we did set it up to be on the edge at full speed for the 240 because we want to have the heat capacity there to show the difference between the bigger solutions when we get to the end. So you can distinguish between a full 3 radiator loop and a 360 AIO. We couldn't just do it at like 100 watts because they would all look the same.
Yeah, true.
Yeah. So now we're gonna have a look inside the case, explain the layout a little bit so you can see our setup for this, look at the hardware, and swap in the 360 for the next round of tests.
We wanted to do like what would be the optimal solution for an average user. So we have like the 3 fans blowing directly into the graphics card, and the 3 fans giving extra air to the AIO. And now we're just gonna swap it out for this 360 one and see if it does any better.
Yeah.
As it should.
Yeah, so our airflow was massively positive pressure. All the lower fans are intakes, the side fans are intakes, and just the 240 and the rear fan were exhausting. So we have nice cool air and no recirculation around the top of the case, like the AIO is not pulling air back through the empty slot, and it's fair between 240 and 360, that they're both fed adequate amount of air. And we also chose to use 2 different systems to compare custom loop to AIO. Because the AIOs are 120 base, they'll have 120 fans. We're using the original Evo XL, and for custom loop we're using the, no. This is the original O11D XL. Yeah. For custom loop we're using the Evo XL.
Yeah, so we can put in 420s.
So we've finished our testing with AIOs for the moment. We will come back to the direct die AIO eventually, but we need to finish all the testing with the IHS on first. So we're going to swap the motherboard from the AIO test system to the custom loop test system, so everything's fair. It's going to be the same CPU, same motherboard, same power supply, everything the same, with the exception of the cooling. In this system, we have 3 P420s with the 011 Evo XL distribution plate, so we'll have a single D5. For the full speed test, we'll have, just like we did with the AIOs, we'll have the pump at full speed. For the 35 decibel test, we may need to just lower the pump slightly. And we'll see. Yeah. So we'll probably tune the pump first to 35 decibels and then the fans afterwards.
Yeah, we'll do it like that.
Results-wise, from the 360, we saw an improvement with one run. We saw an improvement after 10 minutes in the Cinebench scores, but it still failed at 35 decibels to keep the CPU under 100 degrees, so we don't have a temperature result for our manual overclock at 35 decibels yet. And we're hoping the huge surface area of the custom loop will let us pass that easily.
Yeah, let's go building.
Go build. Here we have the performance results from all of our tests. They all start off remarkably well, and actually the peak score from every cooling solution is quite similar. We have a range of just a few hundred points from the best to the worst, but where it gets interesting is how the score is affected over time. So when the CPU is continuously loaded, not just for one momentary test where all the thermal solutions can perform quite well, but when it's loaded for 10 minutes, what the result will be at the end. The biggest spread seen by far is with the AIOs, and particularly the 240 AIO, which has a much smaller surface area. It's unable to keep up with the sustained load from the CPU. So there we see quite a big disparity, especially at 35 decibels, how it performs at the end. Whereas the custom loops, which have a huge surface area, big capacity of coolant, they're each running like triple P420s. They have a very tight window from the peak performance that they give to the worst result after 10 minutes.
Yeah, it's basically the small difference in the coolant temperature. So we can clearly see that the AIO is good for quick burst loads, but when you come to a sustained load, like a long render, you will notice the difference.
Especially when you also want it to be quiet, right? When you compare the 100% flat out, actually even the 240 AIO keeps up quite well, but the deficit at 35 decibels is a lot more. It is important to note that this graph is quite cropped, just not like a massive percentage, and the best to the worst performance result here, but nonetheless, there is some, it's repetitive, and you can genuinely observe a performance difference.
So yeah, if you want a quiet system that performs well, no matter how loud or quiet it is, the best way to go is with custom loop.
Yeah.
And we showed that quite clearly here.
Yeah, but if there can be no compromise between all-out performance, long-term performance, and ultimate like quietness, the only way to do it is with a very big surface area of radiators, and they do it very well. One thing that two things that I do find interesting here. One is the 240 is practically identical to the 360 in its peak performance. I kind of wouldn't expect to see that.
Yeah, it's but in such a short burst, the difference is so small. Probably the coolant can't even get as hot, and the components are basically all the same except the red space.
Yeah.
So the difference is so negligible in those short bursts, but when you see the sustained load, the difference becomes apparent.
And then I guess the other thing to remark is that I would not have expected such a big difference for the custom loop that had 3 P420s between 100% and 35 decibels. Not from the fan speed alone. So perhaps we had also limited the performance there with the pump speed.
Yeah.
I think that is something we should quickly go back and check.
Okay, let's do that. Okay, so here are our thermal results. I think this is what all of us have been waiting for. And it's really good. I think the graph will show exactly what we wanted to show. And you guys will have a great idea of what to expect from our products. So we did a static overclock of 4.8 gigahertz. It reached around 185 watts. We used Prime for this test, and yeah, the results are as expected.
Yeah, and very good. So it started off again. We also have a 35 decibel test where the AIO was running at 100% pump, 100% fans, and the same for the custom loop. Again, the custom loop had 3 P420 radiators with 10 FPT 140s in there. The AIO loop had 10 FPT 120s. So a little small difference, but again, both representative setups of what someone would install.
Exactly. Yeah.
In the best case scenario. And what we see is the 240 and the 360 AIO were unable to pass with our overclock at 35 decibels. The BIOS forced the fans to ramp up, and if the fans didn't ramp up, the CPU would have throttled, and then it wouldn't have been 185 watts. So they're on the graph here, but really those bars should theoretically be bigger. It would have maybe had to run at 105, 110 degrees to pass this test, which is not acceptable for a sustained load.
So it's a failure, yeah. The red bar means it did not pass.
But then if we take the 100% fan speed result, every solution passed and would run this like constant 4.8 gigahertz, which is great. And obviously, initially, from 240 AIO to 360 AIO to the Velocity 2 running 3 P420s, we see a very nice improvement, almost linear between the three as the surface area goes up. And then comes an absolutely massive jump for the direct eye products.
Exactly, yes.
So like this is a really nice leap, and it's nice that it's seen profoundly both for the AIO, like the AIO going from a 360 to a 360 AIO with direct eye has exactly the same benefit as the custom loop does going from non-direct eye to direct eye.
Exactly, yeah. And if you can see the bars, like the 360 AIO and the 420 couldn't even handle the noise normalized test, but like the 360 AIO direct eye did, and with flying colors. And at max performance, the gap was even bigger. So here you can clearly see that with a direct eye AIO, you can have a more quiet system while it still performs. So yeah, this is really cool.
Yeah, there's no way around that. Like the direct eye AIO categorically outperforms the custom loop. I guess the exception there is that there's no benefit for your graphics card. It was a loop with the GPU inside in the same way that the air-cooled system had an identical air-cooled GPU inside. We didn't load it for this because we would just have an exponential amount of testing, what to do with different GPU cooling as well, and every combination. So just looking at the CPU, it's a remarkable result for the direct eye AIO. Yet it is still beaten quite distinctly by the Velocity 2 with direct eye, with the big loop. And I think one other important thing to note is that the AIOs with their small surface area, they have a big disparity between their performance at 35 decibels versus their performance at 100%. Whereas custom loop, we can see from both before and after almost the same gap there, right? There's like 4 or 5 degrees between how it performs at full speed and super quiet. But as remarked in the performance testing, I still find that a big difference for what is just, I think the highest power draw we saw here was 240 watts on the CPU.
Yeah, something like that.
For a loop with 3 420s, that is kind of unexpected.
True.
You would expect at 1,000 RPM, that would still be more than enough airflow for 240 watts.
It's still overkill. It should be more than enough, yeah. So we actually did another test just for this. So again, Prime95 fixed overclock, just like before. But for the custom loop, we gave it a chance and we noise normalized the fans, but we let the pump go to 100% just to see if that might be the bottleneck or we could gain some cooling performance there. And like our suspicions were correct. So
yeah, here you can see that with the pump at full speed, but the fans at their reduced RPM, the performance is much closer to full speed fans than it was to with also the reduced pump speed. So obviously we dropped the coolant flow rate a little bit too low. We didn't have quite enough pump power available for how big and restrictive the loop was. So yeah, 50% was just a little lower than it should have been there, which is unfortunate, probably due to where we placed the microphone when we were doing the noise normalization checks in the beginning. We had it in front of the system by 1 meter, but it was pointed directly at where the pump is on the distro plate. So I think we picked up more pump noise than fan noise, just because of the directionality of it. And so, you know, had we taken a different angle, different position, or averaged multiple positions with the microphone, we would have probably then picked a higher pump speed and got closer to the results we have here.
Yeah, exactly. So hopefully we showed you guys that like the true power of a custom loop. It's really, you can just increase the radiator surface area as much as you want, or as much as the case allows it. And that is like the true power of water cooling. You can really create and add the extra radiator space and it shines. And like...
yeah, that doesn't necessarily get you the performance, because a 360 AIO at full speed, it matches the velocity with 3 P420s at half speed, or approximately half speed, half by PWM anyway. So the fact they match up to each other, you can come to the performance, but not at the same time as the noise level.
Exactly.
You know, if you want to have everything at once, a sustained load and ultimate like quietness, then custom loop works.
Exactly. Yeah.
And then if you want to have ridiculous temperatures, then direct eye works.
Then direct eye works, yeah.
Do you think we could have made any other improvements in methodology throughout that stuff?
I don't know. I think I'm pretty satisfied. I think people, at least people have like a specific use case that they want to test it on. So like maybe a Cinebench core is, people can't really put it into real world applications, or what does that mean? Yeah. I mean, you can maybe do the calculations in percentages, what's the difference in the scores. I think this is fine. I think you guys can clearly see the benefits of all of our products, how they stack up. Yeah, I hope you appreciate it and like it.
Yeah, it was a lot of work to do that much, and I know how comments always go on these videos. It's like, what if you just tested this? What if you just did an overclock for every single thing? Yeah. And it's like, okay, when do we stop? Do we do an overclock at both noise levels? Because there will be a different overclock, so then it will be a lot more work. Yeah. But yeah, I think you can very distinctly see the differences in the solutions. We were not trying to show our overclocking ability, our like luck with the silicon lottery and how good our CPU sample is or anything like that, or even really make comment about the performance of the CPU itself, just what result you get with which solution.
Yeah, how everything behaves out of the box and in setups that might be in your home right now.
Yeah, hopefully it was very insightful, and if you would like to see more of the deliding process because you think the risk is worth it for the temps, go and check out the how-to video on deliding with AM5. And if you enjoyed this video, let us know and we will come back with the same thing for Intel. So no one can say that we're biased towards AMD.
Yeah. What would you say, like and subscribe, or?
I think people say that too much and people don't like and subscribe enough.
Yeah.